In this problem, we are given that the total energy of the particle is 0 and the wave function of the particle in one-dimensional potential is given by this function. We have to find the potential for the particle. Let us now solve this problem. Since E is given to be 0, so we take it as equation 1. So the wave function psi is given to be this, and this capital A and small a are constants, so we can write the wave function like this. Let us now differentiate psi with respect to x. On differentiating psi with respect to x, we will get this expression. Let us now differentiate this with respect to x one time again. On applying product rule, you will get these expressions. When we simplify, it becomes minus 2a into 1 upon x square plus a square whole raised to power 2 minus 4x square and x square upon a square whole raised to power 3 in the denominator. And when we take the LCM, it becomes 2a into 3x square minus a square upon x square plus a square raised to power 3. Now we know that the time independent Schrodinger equation in one dimension is given by this expression, d2 psi by dx square plus 2m by h cross square e minus v psi equal to 0. We can now put the values of e. Remember that e was actually equal to 0 and v has to be found. So when we put these values of psi and e, then it will simplify to this. This value actually came from the previous slide, and this psi is also given to us. Now you will take this term to the right hand side. Upon taking this term to the right hand side, this 2a will get cancelled on the both sides. Now we will cross multiply both sides. Upon cross multiplying, we get the expression of potential as h cross square into 3x square minus a square divided by x square plus a square raised to power 2. Therefore the correct choice will be A.